Okay, I'm keeping the base really light today. I'm using just a little primer, mostly where my makeup tends to move. Then I'll bounce in a little skin tint. I still want my skin showing through. Just a little concealer where I need coverage. I'm pressing powder under the eyes and through the center so everything stays fresh. For the brows, I'm only filling the sparse spots and keeping the shape soft. I'm keeping the eyes soft with warm neutrals. I'm keeping the liner thin, just enough to define the lash line. Then one light coat of mascara so the lashes stay separated and natural, which brings everything together. For the lips, I'm using a soft nude with a little shine, and that's it. Fresh, polished, but it still looks like me.
I got you, buddy. I got you.
These shots didn't begin with a text prompt alone. I gave LTX 2.5 an opening image for the first frame, a target image for the last frame, and a timeline describing how the action should move between them. After that, I used those generated videos to create entirely new videos. Here's how I created that makeup sequence by combining 4 separate clips. First, I generated all the images I needed using GPT Image 2. For each clip, I used 3 reference images and 3 segment prompts. 1 segment prompt for each image. Here's the resolution I used, and you can also see all the other settings, including the clip length and frame rate. Starting with the second clip, I reused 1 second from the previously generated clip to lock in the audio and keep it consistent throughout the entire sequence. I encountered a few issues while generating the clips. For example, the woman's hands came out of the mirror, so I had to crop that part out. You can fix many of these issues by refining the prompt and running multiple generations, but most of the time, it simply isn't worth the extra effort. You can do a lot of amazing things with this workflow, but its limitations are still the limitations of the model itself. And LTX 2.5 still has a lot of limitations. Everything was generated locally in ComfyUI on my RTX 5060 laptop. That's 8 GB of dedicated VRAM, but the workflow also relies heavily on my 32 GB of system RAM for offloading. Director 2.0 is a community custom node created by WhatDreamsCost. Make sure to show him some support for his amazing work. Director doesn't make the base model smarter. It gives us a practical way to arrange images, videos, prompt changes, and audio on a single timeline around the model's existing abilities. As always, make sure you update ComfyUI before running the workflow. Here are the download links for all the required models. The model stack is the same base stack from my earlier LTX 2.5 video. The 22 billion parameter distilled INT8 convrat transformer, the matching Gemma 412 text encoder, and the LTX 2.5 video and audio VAEs. Inside the KJ loader, I used FP8E4M3 weights, enabled the Kublas linear patch, and selected the Sage Attention mode shown on the screen. If you haven't installed Sage Attention properly, make sure you keep it disabled, otherwise it will break your generation. Chunked feed-forward processing is set to 2 chunks, with the threshold set to 4096. For sampling, I used Euler Ancestral with the simple scheduler, 8 steps, and CFG set to 1. The Director guide uses image attention at 1, center crop, automatic grid snapping, and tiled encoding at 256 with 64 pixels of overlap. The final video VAE decode is tiled at 320 with 64 pixels of overlap. If you get an out-of-memory error during the VAE decode node, you can try reducing the tile size to something like 256. I've also attached the official size settings reference here. Stick with these resolutions to help prevent artifacts in your videos. For video-to-video generations involving people, my preferred resolution is the one you see on the screen. I successfully generated clips up to 10 seconds long at 24 frames per second using this resolution. For a low VRAM starting point, use a shorter clip, restrained camera motion, and 2 guides with closely matched compositions. Split the action into 2 or 3 phases, hold the seed while testing your prompts, and only raise the resolution or duration after the movement works. The visual consistency is strong enough to produce shots I would genuinely use. Complex action remains unpredictable enough that I wouldn't schedule an entire production around getting one perfect generation. I'll leave the tested workflow and all the required links below. If you try it, share the type of first and last frame shot that worked best for you, along with your GPU, resolution, and duration. That makes the result much more useful to everyone testing on similar hardware. Thanks for watching. Leave a thumbs up and subscribe if this guide helped, and I'll catch you in the next one.